Hey everybody, this is Mr. Mazzoro, and today I want to talk to you about the gases that are in seawater. We already talked about the salt that's dissolved in seawater, but there's also gas dissolved in seawater. Carbon dioxide and oxygen and nitrogen, the same gases that are dissolved in air. How do they get into water, and what are they doing there? That's what I wanted to talk to you about today. So, how do those gases get into seawater? It's weird to think about water having gas in it. Well, you actually have direct experience with a liquid that has gases dissolved in it. If you think of a bottle of Coca-Cola or any soda, you look at that closed bottle, it's liquid. But as soon as you open that bottle, you can see all the gases that were dissolved in that liquid bubble out. How does that gas get into that liquid? Well, it becomes dissolved. But where does it become dissolved from? If you're seawater, the gases in you come from three places: air, photosynthesis, and respiration. There's gases in air, there's air above water, and that's one of the ways that all those gases get into ocean water. Also, photosynthesis. There's lots of photosynthesis going on in the oceans, from phytoplankton to seaweed, even to marine plants. And they're taking gases out and putting gases in the same way as organisms breathing gases in and breathing gases out. And those are your three main sources of gases in water. But even though there are the same types of gases in air and in water, they're not in the same concentration. For instance, nitrogen. If you take a gulp of air, if you breathe in air, about 80% of that air that you're breathing in is nitrogen. But if you take that same gas, nitrogen, in water, that only makes up about 11% of the total gases in water. And then there's oxygen. When you breathed in that 80% nitrogen, you were also breathing in about 20% oxygen. But water has much less oxygen in it. 6% of the oxygen, 6% of all the gases in water is actually oxygen. And then even more weirdly, when you breathed in that air, less than 1/10 of it was carbon dioxide. But carbon dioxide makes up a full 83% of all the gases in ocean water. If you compare the amount of carbon dioxide in ocean water to the amount of carbon dioxide in air, there's way more carbon dioxide dissolved in ocean water than in air. Why? Well, we're going to get to that, but let's do oxygen first. In order to show you how oxygen changes in the ocean, I have to show you an ocean profile. This is the main graph that marine scientists use to show how anything changes with depth in the ocean. On the y-axis, we have depth, and it's in reverse order. So as you move down the y-axis, you're getting deeper and deeper and deeper into the ocean. On the x-axis of an ocean profile, there could be anything. There could be salinity, there could be temperature, there could be oxygen, which it is in this case. There could be nitrogen, carbon dioxide, the amount of light, the amount of organisms, whatever. The farther you are to the right of the x-axis, the more of that something is, and the farther you are to the left of the x-axis, the less of that something there is. And so you can see how something changes, the quantity of anything changes with depth in the ocean. So let's take oxygen. Look at the amount of oxygen on the surface. There's a ton of oxygen on the surface when you compare it to other areas of the ocean. Why? Well, the answer is because there's lots of light and lots of air on the surface of water, and that air and light for photosynthesis causes there to be lots of oxygen on the surface. As you move down in the ocean from the surface, deeper and deeper and deeper, your amount of oxygen rapidly drops off. Why? Why is it getting lower and lower and lower? Well, 500 meters down or 1,500 feet, there's no air and there's no photosynthesis. But there is still organisms, and they are still breathing. So on any body of water that's deep enough, what you get is this area where you don't have any light or photosynthesis putting oxygen in, but you do have lots of organisms sucking oxygen out. And that area is called an oxygen minimum zone. What's even weirder about oxygen is that after we get past that oxygen minimum zone and start going deeper, our oxygen starts going up again. There's still no light and still no photosynthesis down deeper in the ocean, but yet all of a sudden our oxygen starts going up. What's putting oxygen down below there? The answer for that is downwelling. You remember that downwelling, when I was teaching you about currents, takes cold, salty water, and it sinks from the surface. And as it sinks, it brings with it oxygen. And once it gets to the bottom of the ocean, there's less organisms to breathe it. So that oxygen basically just sits there. So the amount of oxygen changes with depth. Lots of oxygen on the surface, little in the middle, lots down below. Oxygen on the surface because you have lots of light and photosynthesis. Little in the middle because you don't have any light or photosynthesis, but you still have lots of organisms breathing. And then a lot down below due to downwelling and due to the fact that down deep in the ocean, there's less organisms overall that's breathing. So next I want to talk to you about carbon dioxide. If you remember, I said that most of the gas in ocean water is carbon dioxide, way more than the amount of carbon dioxide that's in air comparatively. So why? Why is carbon dioxide the number one gas in ocean water? The answer is carbon dioxide is the only gas of the three major gases in ocean water that reacts chemically with it. Carbon dioxide reacts chemically with water, and it actually causes water to become slightly acidic. In the right proportions, this means that carbon dioxide helps stabilize the pH of the ocean, keeping it at a pH of 8. But if we get too much carbon dioxide in the ocean, then we cause the ocean to become too acidic. And over the last 100 years, there's been more and more and more carbon dioxide in the atmosphere, which means there's been more and more and more carbon dioxide being dissolved in the ocean. And as a result, the oceans are becoming more and more acidic. This is known as ocean acidification. As the oceans become more acidic due to the increasing amount of carbon dioxide that's becoming dissolved in them, a lot of the organisms in the ocean are starting to suffer. Number one, organisms with shells. Stuff like coral and clams and snails. These shells are made out of limestone, and limestone dissolves in an acid. So the more acidic we make the oceans, the more these organisms' shells start dissolving in the water that they're trying to live in. Then you have other organisms that have exoskeletons made out of chitin, like crabs and lobster and crayfish. And these organisms also have their exoskeletons softened and start to dissolve due to ocean acidification, due to the excess amount of carbon dioxide in water. Coral makes coral reefs, sucking carbon dioxide out of the air and water and actually hardening it into rock. But again, too much acid means that rock starts to dissolve and put that carbon dioxide back in. And as a result, coral reefs have trouble forming and reforming. Now, fish don't have exoskeletons or shells, so how would they be affected? Well, the same way that we're affected by too much carbon dioxide. They start to suffocate. Too much carbon dioxide in the water means fish are harder to breathe, especially smaller fish, which means that those small fish can't be food for the big fish, and there's less food overall in the ocean. So, ocean acidification is caused by excess amounts of carbon dioxide dissolved in ocean water. That excess amounts of carbon dioxide dissolved in ocean water means that the oceans are becoming more and more acidic, which starts harming organisms with shells and actually causes organisms in the ocean to start to suffocate. Last but not least, there's nitrogen. We talked about oxygen, we talked about carbon dioxide, now let's talk about nitrogen. How does nitrogen get into water? Well, from two places. One, lo and behold, the atmosphere. There's tons of nitrogen in the atmosphere, if you remember. It's 80% of the air in the atmosphere. So that means that nitrogen enters water because water interacts with air. The other source of nitrogen in the oceans might surprise you. It's actually from fertilizer, and not only fertilizer from farms, but also from your lawn. When you fertilize your lawn or your garden or a farm or a golf course or whatever, there's tons of nitrogen dissolved in that fertilizer because it helps plants grow green and tall and lush, just like you want your lawn to be. The problem is there's so much nitrogen in fertilizer a lot of the time that plants can't use it all. And if it rains, that extra unused nitrogen gets washed ultimately into the ocean. Just like it causes your lawn to grow greener, that extra nitrogen in the water causes the water to grow greener. Only now it's not grass, now it's algae. Now, this is called eutrophication. Excessive algal growth due to excessive amounts of nitrogen in the water. And on its surface, at the beginning, it's not necessarily a bad thing. I mean, too much algae, a little bit of green water never hurt anyone. But the problem is that all that extra algae starts to begin to overcrowd itself and die. And when it begins to die, it sinks to the bottom and begins to biodegrade. And the bacteria that does that biodegradation sucks all the oxygen out of the water. Since there's so much algae in the water and so much death in the water, that means there's tons of degradation in the water. And eventually, the water becomes completely and totally oxygen poor. And so oxygen poor that all the life inside of it begins to suffocate. Eutrophication is what happens when too much nitrogen in the water causes algae to grow out of control. And then when it dies, excessive amounts of oxygen to be sucked out of the water due to when the algae begins to biodegrade. So that's it. We talked about the three main gases in water: carbon dioxide, oxygen, and nitrogen. And then we talked about how oxygen changes, how there's lots of oxygen at the surface due to light and photosynthesis, a little oxygen in the intermediate zone right below the surface due to a lack of light and photosynthesis, but still a lot of organisms breathing, and then a lot of oxygen down again below that area of the oxygen minimum zone due to downwelling. We talked about how carbon dioxide affects water, turning water more and more acidic and necessarily causing ocean acidification and organisms with shells and fish to begin to have their shells soften or dissolve and fish begin to suffocate. And lastly, we talked about nitrogen in water and how it enters not only from the atmosphere but through fertilizer. So excessive fertilization means excessive nitrogen in the water, which causes algae to begin to grow out of control and eutrophication to take place. That's it. Those are really what I wanted to talk to you about with the gases in ocean water and how gases change and affect ocean water as a whole.